Well, hello everyone. Good morning, good afternoon, good evening, wherever you are in the world. Thank you for tuning in to this product webinar to introduce Delta Q's series of chargers. I'm Paul Drabble. I'm the Senior Marketing Manager at Delta Q Technologies, and it's my pleasure to welcome you to this product webinar brought to you by Delta Q and our parent company, the Zappi Group. I'll do start with a quick overview of the webinar agenda and introduce our two speakers. Timing-wise, our presentation will take approximately 30 to 35 minutes. And in the remaining time, we'll open that up to questions you may have. Lastly, we will record this session and provide a link to the recording along with the slides to all of the attendees for the webinar in the next week. Okay, just a quick look at the agenda. Our speakers are going to talk about Delta Q's mission, our OEM customers that we have, and also battery partners that we partner with. And then we'll get into the presentation, the actual overview of the RQ series battery chargers, the markets applications, the product features that you're interested in, and then finish off with a summary and question time. Okay, and if you have questions, please submit them. So you'll notice in your GoToWebinar control panel, there is a questions chat tab there. So just open that up, submit your question, and we'll compile those questions and we will answer them at the end of the presentation, not during the presentation, but at the very end in order of the submission. So we'll go as long as we get questions, and if we have very few questions, then we'll finish early, but otherwise, please submit your questions using the chat panel there. So with that, we've got today's speakers. We've got Jeff Everett, who is our Director of Product Management at Delta Q Technologies, and the RQ Series Product Manager, Sunil Adaluri. Okay, so again, with that, I'll pass the speaking on to Jeff, where we can talk about Delta Q and our Charge the Future story. Over to you, Jeff.
All right, thanks, Paul. Delta Q Technologies is part of the Zappi Group. Zappi is a global leader in electric motors, motor controllers, battery chargers, autonomous navigation, and auxiliary components for battery and hybrid power electric vehicles and machines. Here at Delta Q, our focus is on battery chargers and battery charging, and it's something we've been doing for more than 20 years now. We believe strongly in an all-electric future. We're passionate and excited about working towards a sustainable future and extending electric drive systems, including batteries and chargers, from traditional applications like lift trucks and golf cars, floor scrubbers, to new markets, new applications such as robotics, e-mobility, construction equipment, and a whole lot of other applications. We're constantly seeing and evaluating new applications and excited about charging the future. Delta Q's mission is what we really want to do is partner with OEMs and work with you to provide the right solution that enables your success. To be a strong partner, we're always innovating across our product portfolio. We'll talk about some of that today, our technology and our business. And it's more than just providing robust charging solutions. It's having the ability to scale with you to support your demands, with having high volume automotive grade global manufacturing in China, Mexico, and this year a new plant in India. Last year we built and shipped over 600,000 chargers, and so we're building capacity to continue beyond that to support you. It's also about having customer service and support. We're headquartered in Vancouver, Canada, but we have sales and support offices across North America, Europe, and Asia, plus a number of distribution partners in 18 different countries. It's been a robust Partner is about on-time deliveries, providing logistical support when needed, even in times when part shortages are rearing their heads, like we've experienced the last few years. And it's about having quality and continuous improvement. We have very low product returns, less than a fraction of percent. Our standard process is to bring every unit back that fails in the field for analysis so we can learn from it, identify new issues, and make improvements. So our aim is to be our customer's supplier of choice, the safe pair of hands working with you towards the common goal of all electric future. Next slide, Paul. This slide is, it just shows a sample of high volume OEM customers that we partner with and service today. Our OEM customers represent a wide number of markets with a wide range of needs. Some are more automotive process driven. Some have very difficult use cases with high shock, high vibe environments. And some just push their batteries extremely hard and really abuse their batteries. We are proud to be working with some of the top OEMs in the world and are honored that they've put their trust in us. Next slide. Another thing that we do, which we believe is quite important in supporting our OEM customers, is closely working with and partnering with reputable battery suppliers and manufacturers. And this slide just shows a few of our Charged by Delta Q battery partners. We know through experience that using the wrong charger or the wrong charging profile to charge a battery bank can lead to poor outcomes, premature battery failures, unsatisfied customers, and even worse, safety issues. So Delta Q has made a significant investment in a large battery lab, number of test channels, and we will and we do work closely with the battery manufacturers to ensure that there is charge quality, that the charge quality is high, and that your customers will get the most out of what is typically one of the largest cost components in the system, the battery bank. The goal is to avoid these situations where expectations haven't been met in the field and everyone's wondering whose fault it is, starts finger pointing. So we want to work with you and support you alongside the battery supplier, making sure that companies are like-minded and we're providing a reliable system upfront that prevents this from happening. So now I'll turn it over to Sunil to talk about our RQ series and what's new.
Thank you, Jeff. Hello, everyone. Today, I'll be providing an overview of our RQ series product line. So the RQ series is newly introduced by Delta Q. These chargers are compact, they are rugged and highly efficient automotive grade battery chargers. So you can see in the diagram to the right, we have two chargers as of today, the RQ350 and RQ700. So the 350 and 700 stands for the power output of the chargers respectively. And these chargers have key features tailored to market requirements today. Some of them include the 12-volt aux output, UDS support. UDS stands for Unified Diagnostic Services, and CAN support as well. These chargers were primarily designed for light electric vehicles, outdoor power equipment, pallet trucks, and other industrial vehicles and equipment. Next slide, please. So yeah, here I'll talk about the market segments where the RQ battery chargers are used. So we have a different range of markets where our chargers are used today. So we have outdoor power equipment, machines like lawn mowers and others, which are working in harsh environments. We have golf utility vehicles. We have e-mobility, electric bikes. We have some construction machines using our chargers. Then we have MEWP market segment. MEWP stands for mobile elevated work platforms. So in the diagram, you can see a scissor lift machine here, and those use our RQ chargers. Then we have material handling and floor care machines. And also there's robotics where these chargers are being used. Next slide, please. So our main focus at Delta Q is to provide a very high quality and reliable product to our customers. And for that, our engineering team does a series of rigorous testing of our battery chargers to meet the required quality standards. So we have 3 legs of testing, which we usually perform on our chargers. The first leg consists of a drop mechanical shock and vibration test. So we follow a General Motors standard called GMW 3172 that has very high requirements for shock and vibration tests, and our testing is adheres to that quality and automotive level of testing as followed by General Motors. So it's similar to how if we mount a battery charger to a vehicle and the vehicle goes on a bumpy road or a road with a lot of potholes with extreme shocks. So we put our chargers under those kind of stress levels to determine its reliability. The second leg of testing consists of temperature and humidity testing. So our chargers are put to temperature tests, like with extreme temperatures ranging from the hot to the cold side. And also we have different varying humidity levels to see how the charger performs under these conditions. Basically, we try to simulate the environment and the conditions in the field in our labs so that we know like through how many cycles and how many different stress limits our charger can go so that we deliver good performance all the time. And the third testing under the third leg testing consists of a salt fog test where there's a mist or a fog which has salt, and the charger is exposed to this mist. So this test basically tests how resistant the charger is to foreign particle ingress, whether it's dust or moisture. Since our chargers are IP67 rated, we ensure that there is no room for dust or moisture ingress, and this test is just used to validate that. And lastly, HALT, it stands for highly accelerated life test. So HALT is basically a testing methodology that we use to identify the weak links in our product, whether on the design side or on the manufacturing side. So it is subjected to random vibrations and high temperatures and fluctuations, or a combination of both while the charger is powered on or powered off, to see how much stress the power electronic components within the charger can take. Based on the HALT testing, if you are able to identify any failure modes upfront, we have a chance to address those issues and fix the product, so that when the product goes into the customer hands, it's fully validated and it's a reliable quality product. Next slide, please. So as I mentioned, reliability is in our DNA of Delta Q. Our goal and our promise to our customers is that we provide a highly reliable product which will have a long life. So you can see that it is compact, sealed, and rugged. The design here shows that. The RQ350 is IP66 rated, whereas the RQ700 is IP67 rated. Both are convection cooled. Both are tested for automotive shock and vibration, as I just explained. And these chargers are suitable for both lead acid and lithium-ion batteries for all chemistries. Next slide, please. The user interface also is quite simple, so that the end user or the operator who's using the charger can easily understand the charging status and other functions. So basically, we have 3 LED lights which indicates the AC input. The blue light indicates an AC input. The green light shows the charging status, and the red light shows an error or a fault. So the AC input signal is very important because we've had cases in the field where customers or the operators complained that the charger failed, and upon investigating the root cause, we found that the AC source was not connected. So having this indicator upfront eliminates this problem, and the operator can know that the charger is connected to an AC source, and the blue light indicates that. So that can be taken away if there's any other issue. The green light shows the charging status. So basically we show three different stages or levels of charging. From 0 to 80%, it's called a low state of charge, and we have a slow flashing green light which shows that it's in that range of 0 to 80%. From 80 to 100%, we classify it as a high state of charge, and that is indicated by a fast flashing green light. And when the battery is fully charged and reaches 100%, the LED light turns solid green, saying that the charging is complete. And if there's any issue or problem in the charging process, we have an red LED light which flashes to indicate an error or a fault. And we also have different error codes. So based on the number of flashes of the red LED light, it corresponds to a particular fault in the field. And all these error codes are given in our user manual. Over the LED lights, we have a membrane button, which is used to indicate the charge algorithm. And you can also use that button to change the charge algorithm. Yeah, next slide, please. So charge profile is very important. As Jeff mentioned previously, it is very important to have the right charge algorithm for a particular battery type. Today, we have over 250 charge profiles or charge algorithms, along with partnership with all these companies. And a charge algorithm is important, and we need to select the right charge algorithm in order to optimize the battery life and maintain good battery health. So selecting an algorithm depends on the chemistry of the battery and also on the capacity and other factors. For example, under lead acid, we have a flooded lead acid, we have AGM and a gel type of battery. And under lithium ion, we have different chemistries today, some of them being the LFP and NMC. So for each different chemistry, a different charge, a particular or a specific charge algorithm should be used. For example, a lead acid battery usually has to be overcharged, and the algorithm usually charges 10% more for a flooded lead acid battery, whereas for a lithium ion battery, it usually charges 2% more, so around 102% in usual cases. So if I use a algorithm for a flooded lead acid battery on a lithium battery, it will end up overcharging the battery and thus damaging the battery. Whereas if you use a lithium ion battery charge algorithm on a flooded lead acid battery, it will undercharge the battery, and that it will negatively impact the battery health and life. So it is very essential that we choose the right algorithm. And our team at Delta Q is expert in recommending the right algorithm for your application and battery pack. So once we know your requirements and the specifications of your battery, our team can suggest a suitable algorithm which is best suited for the battery pack, which will maintain good battery life and health. Next slide, please. We also support the CAN bus communication. So the two common protocols that we use are the CAN open and SAE J1939. SAE stands for Society of Automotive Engineers, and they have this J1939 standard. We use the standard, but we are able to customize the kind of messages or information we send based on our customer's request. And these communication protocols help in getting the charge cycle data and analyzing them. We can do a software update over the charger or set up new charging profiles. And for lithium ion batteries, we can give the battery management system, the BMS control to interface to the charger. So this is a very useful feature of our RQ series chargers that we have. Next slide. So we want to be the supplier of choice for our customers, and we take great pride in partnering with our customers and providing them custom solutions. So if any of our OEM customers have high volume requirements, we are happy to help them with product customization, and that includes engineering development both on the hardware and the software side. We can also work on special regulatory certifications that may be needed. We can help in custom branding or co-branding, and also help on labeling and bulk packaging. So please note that this is just for high volume customers who want to order chargers in large quantities, and we would be more than happy to help them in this development. Next slide, please. So the RQ350 and RQ700 come in standard offerings. So we have a base model for both the chargers and also a COM model. If you see the images on the left, on the base model, we have the charge profile button and the LED status indicators, which I've explained before. And there's a DC terminal which connects to the battery positive and battery negative, and it also has the interlock and temperature sensor. So the AC connector used here is the IEC 320 connector, and for DC we use a 2-meter cable connecting to the battery positive and negative, and it comes with ring terminals with temperature sensor and interlock signal. On the COM model, it has all the features of the base model as shown, and in addition we have a signal connector which supports CAN bus communication, the NO/NC COM interlock, the 12-volt auxiliary output power, and also remote LED capability. The connector used for the AC is the same. It's the IEC 320 connector, and the DC is the 2-meter cable. The signal connector is different on the RQ350 and 700. So on the 350, we have an Amphenol 8-pin connector, whereas on the RQ700, we have the Amphenol 12-pin connector. But rest all in terms of features, the COM models of both the 350 and the 700 provide these additional features mentioned here. Next slide, please. So this is the OEM offering for the RQ350 and RQ700. So we have a COM-D model and an MPP model. The MPP stands for multi-purpose pin. And if you see the COM-D model, it has the same indicators as the other base model and COM models, like you have the charge profile button, the LED status indicator, and the DC terminal. The DC terminal, however, has up to 6 signal wires, which can be configured by the customer as per their requirements. So usually 2 of them are configured for CAN high and CAN low, but it's entirely up to the customer how they want to use these signal wires for their application. The AC connector is the same IEC 320 connector, and the DC is a customizable length connector. For the MPP, we have the 4-in-1 MPP, that is, those include the interlock, the temperature sensor, the safe disconnection, and LED. And the DC cable is a 2-meter 16 AWG with MPP paddle. So below the MPP model, you can see the MPP paddle receptacle images. So these are just for representation purpose, but it's just to give an idea that the paddle receptacle for the MPP model charger can be customized based on our customers' requirements. Next slide, please. So here is a quick summary of the RQ series models. So I have listed down the features and also the different models, the base, COM, COM-D, and MPP. So the base model has the status indicators, button, power interlock relay, and the wire temperature sensor. The COM model, in addition, has the signal interlock relay, the CAN communication, the remote LED indicator, and the 12-volt aux output. The COM-D, these features are optional, and I've indicated O here. And for the MPP, we have the signal for interlock on MPP, the temperature sensor, and we have the receptacle LED signal on the MPP. So the customer can choose which variant of the 4 is suitable for their requirements, and based on that, he can go for the particular charger. Next slide, please. So here's a high-level snapshot of the RQ series features. So as I've mentioned, we have the 12-volt auxiliary output. So this 12-volt auxiliary output provides a current of 400 milliamps on the RQ700 and 100 milliamps on the RQ350. So this is used for operation of small loads like BMS wake up. For example, in some lithium-ion batteries, sometimes the battery management system goes into sleep mode, and we can use this 12-volt auxiliary power to wake up that BMS and come out of the sleep mode. Apart from that, this power can also be used in equipments or machines which use telematics, so it can be used to power those applications. We have the CAN, communication and control. Our chargers are EMC compliant, so we comply to both FCC-A and FCC-B for industrial and residential power circuits, and also R10 for onboard vehicles. We comply to the EU touch-safe voltage of less than 60 volts DC. We have global safety and regulatory approvals on our product. So for North America, we have UL. For Europe, we have CE. We have RCM for Australia and New Zealand, KC for Korea, and PSC certification for Japan. The user interface, as I've explained, is simple. It has LEDs and the buttons. The locking AC connector is there to prevent any accidental disconnection of the charger. And we also have AC over voltage protection. If the charger is improperly connected to an AC, so we have over voltage protection up to 420 volts of AC. The high current interlock is it has a debound circuit to protect against shock and vibration. This feature is not there as of today, but it's planned to be introduced in the future. Next slide, please. So these are the electrical specifications of both of chargers. So the RQ350 comes in 4 voltage models: the 12 volts, 24, 36, and 48 volts. The 12 volt RQ350 can provide a maximum power output of only 220 watts, whereas 24, 36, and 48 provides a power output of 350 watts. That's full power. And if you see the max current, it ranges from 15 amperes for the 12 volt charger up to 7.5 amperes for the 48 volt charger. On the other hand, the RQ700 comes in 3 voltage models: 24, 36, and 48. And the max current ranges from 30 amperes for the 24 volt charger to 15 amperes for the 48 volt charger. Next slide, please. Coming to the mechanical specifications, the dimensions of both the chargers are mentioned here. So basically, our charger is very compact and has high power density. So for the volume it has, there is more power output for the volume of the charger compared to other chargers in the market. And this gives us a competitive advantage. The AC input connector, as I've mentioned, is the IEC320 C14 AC connector. The DC output connector is a standard connector with ring terminals. It's also OEM customizable. The signal connector, as I've also mentioned, is an 8-pin for the RQ350 and 12-pin for the RQ700. The 350 is IP66 rated. The RQ700 is IP67 rated. Both are convection cooled. You can see how the fins are placed for the passive cooling, and they are tested to strict shock and vibration as per the GM W3172 standard. And the operating temperature of both the chargers is from -40 to +65 degrees Celsius. Next slide, please. So what are the unique selling propositions of the RQ chargers? So the first one is the 12 volt auxiliary output. The second one is the microprocessor supports UDS, or Unified Diagnostic Services. And the RQ series product package includes the necessary cabling. So the charger comes along with the standard cables. So the customer need not worry about procuring cables separately when they purchase chargers from Delta Q. The benefits of the RQ series are it's a high performance, they ensure high performance battery charging and machine uptime. And since they have the 12 volt auxiliary power, they have good compatibility with lithium-ion batteries. And UDS offers the ability to use standard service and upgrade diagnostic tools. So in case there's any problem with the charger, with the help of UDS, the issue can be identified immediately and troubleshooted with using these diagnostic tools. Next slide, please. So how our RQ chargers are different from other chargers in the market? Well, I've already talked about these features, but here's a list. So we have the 12 volt auxiliary output, the IP67 design, a rugged and compact charger, which is tested to the GM standard. We have CAN bus communication support and UDS support, and our chargers are EMC compliant. So all these features and specifications give us a competitive advantage over other chargers in the market. Next slide, please. So yeah, here is an overall summary of the RQ series. So I've touched upon all these points before, but just reiterating them again. Our main DNA of our company is reliability, so as I've mentioned, and our chargers are very reliable in the field, compact and ruggedized automotive grade battery chargers. We have global safety and efficiency compliance along with EMC compliance. We support CAN communication using the CAN Open and J1939 protocol. And our another important point is our chargers are operational on any single phase. So from 85 volts AC to 270 volts AC. So they are suitable for different countries in Asia, in Europe, and also in North America. So they are globally and universally, they are usable in different applications. Yeah, next slide, please. So yeah, that concludes the summary of the RQ series product line. In case you want to have a sample of the RQ series chargers, you can please log on to this link, https://connect.deltaq.com/sample. There is a simple form that you can fill up and submit. And once we receive this form, our team at DeltaQ will reach out to you and we'll help you out with the process of getting a sample. Yeah, this concludes our webinar, and if you have any questions on the topics presented, please feel free to ask. Over to you, Paul.
Okay, great. So we do have some questions. Thank you very much, Sunil and Jeff. And just going back to our little guide here, if you haven't yet submitted a question and you'd like to, just please refer to your little control panel on your GoToWebinar link there. So the first question that we have so far, is there a design reason why all of the DeltaQ chargers single voltage output chargers versus having a model that can be multi-voltage output, say for example 24, 36 and 48 volt? This would allow the distributor to stock one model of charger per power range.
Yeah, it's a good question. So basically, when we design the product, we identify what the market requirements are, and based on that, we decide what voltage models are required. And our engineering team usually determine the size of the PCB inside the charger based on the lowest voltage model, and that determines in essentially the size of the charger. So we consider each voltage model as a different charger during our development process, and that it's easier and simplistic to keep it that way than to have multiple voltages on a single charger, which could lead to further complications and issues. So in order to have like good performance and reliability, that is the process we follow. Yeah, so that's why we have a single voltage model for all our chargers.
Yeah, just to add to that, one of the potential issues when you do have multi-voltage units is it for example, a 24 volt unit or a 36 volt unit, and if you have the charger itself auto sense, the problem is there's crossover between the voltages. So a very discharged lead acid 36 volt pack looks like a 24 volt pack. And so you can have issues that come up in the field from inappropriately charging batteries. The other side of it too is most of our OEM customers, they're looking for a power level to charge the pack that they put on the equipment. And so there's a compromise. If you say design for a 36 volt pack and you're looking for 700 watts output, when you try to take that to use the same design, same hardware to charge a 24-volt pack, there's going to be current limitations. So it won't be a 700-watt charger anymore. It'll be something less, and that's really that's OEM customers are not asking for us that. So we stay focused on single output voltages across the charger range.
Okay. Next question. What are the potential risks if an inappropriate algorithm is used?
Yeah, so as I've explained in before as well, it's very important to select the right charge algorithm, because if you select an inappropriate algorithm, it could either undercharge or overcharge the battery, and both conditions are not good for the battery life and health. So for lead acid batteries especially, it is essential that we follow the correct charging process. Otherwise, it can negatively impact the battery health. And even for lithium-ion batteries, that is important. Based on the different chemistries, we have to select what kind of charge algorithm we use. Some may have to be charged more, some may have to be charged less. So it's just to maintain good battery health and increase the lifetime of the battery and not damage the battery, that we have to select the right algorithm. So our team sees the battery specifications and determines which algorithm is best suited for that.
Okay.
Yeah.
Next question.
If I can just add to that, so in most cases, as Sunil said, we're talking about performance issues, so shorter battery life. There is a concern with lithium if you charge it with too high voltage, that you can drive a safety issue with doing so. We strongly recommend and advise customers you have to have a battery management system in play there between the battery charger and the cells. We strongly don't endorse systems where there is no battery management system in the system, because that can lead to unsafe circumstances.
Okay. All right. Next question. Can you explain the significance of the EMC declaration and its implications for users, especially in residential installations?
Sure. So basically, the battery chargers emit electromagnetic radiation. It can be either conducted or radiated emissions, and there's a certain limit up to which it is acceptable to be compliant. So if we go beyond the accepted limit, it will affect equipment or other machinery in the surroundings. So for residential applications, it's very important because in residential places, we have different equipments operating, and we wouldn't want to interfere with other instruments or affect their performance by emitting radiations over the limit. One use case could be in hospitals, like where some floor care machines are used. If our battery charger is used there and if it's emitting some radiations, it should not tamper or interfere with other medical equipment in the hospital, which could affect its performance. So yeah, I think that's very crucial why we try to comply to these standards. And we see
I have a funny example of a product that emitted way above the residential limits, and it was a inverter charger used in a RV, and the emissions were so bad that the RV parked in front of people's garage, in front of their house, were causing the garage door to open and close on its own. So it was a nuisance to the homeowner because their garage would open up when they weren't home because of the battery charger on their RV. So there's limits. in automotive, like if you're trying to integrate into a vehicle, there's the R10 limits for on-road vehicles, and basically it's to prevent interference with other devices in the vehicle, like so you don't hear static on the radio when you're plugged in and things like that.
Okay. Next question regarding the charger's robustness. Can you explain why it's recommended to use only 3 of the mounting points when attaching it to a vehicle or machine frame that may flex?
Yeah, I'll take that. So if it's attached to the theory is that if it's attached to 3 points, then there's less if when the frame flexes, there's less torsional moment applied to the charger. So it just reduces the stresses that are applied to the charger from the vehicle itself. I know we've made that recommendation in the past, that I think in a lot of cases, OEMs, there's 4 holes on the charger. Most OEMs use all four holes, and it hasn't caused any problems. So I think it's really up to you guys designing the equipment and how you install it. It's really up to you whether you want to use all 4 holes or only 3 of them. But if you use 3, then it's a more simple mechanical design, and it doesn't transfer the stress to the case when the frame is flexing.
Okay. Next question. How does the charger handle power interruptions, and is there any risk to the batteries or the charger itself when the power is suddenly restored?
I can take this one too. The charger, there's logic in the algorithms and the charger in some it varies, but really the answer to the question, is there risk? No, we try to minimize any risk itself. There's certainly not risk of inappropriate power surges being transferred through the charger to the batteries. There can be instances where if there's a short power interruption and the charger comes back on, that it doesn't know whether it's been plugged in for a long time or unplugged for a long time or a short time. So there's a risk that it will restart the charge cycle. And if it's in a continual mode of power cycling and it's restarting the charge cycle, there is a concern that the battery will eventually be overcharged because of that. All our algorithms take this use case into consideration, and we've wrapped some logic around as much as we can to qualify the battery, check the voltages at the start, and we have timeouts and appropriate timeouts and set points along the way that the battery charger, for the most part, can prevent any overcharging or undercharging of the battery when these kind of chronic situations happen.
Okay. Next question. How does the RQ series contribute to energy efficiency and sustainability in industrial settings?
So our RQ series chargers are compliant to CEC and DOE requirements. CEC is the California Energy Commission, and DOE is the Department of Energy in US. So we have around 93% peak efficiency on our RQ chargers. And based on, since we are compliant with the government regulations, we are contributing to the energy efficiency and sustainability in industrial settings. And even during the product development process, our engineering team does a variety of tests to meet these energy efficiency standards before we finalize the product and release it to the market.
Okay, next question. With up to 25 charge algorithms stored in the charger, how does the RQ series manage and update these algorithms to accommodate new battery technologies?
So our chargers are suitable for both lead acid and lithium. The new technologies are mostly on the lithium-ion side, and our chargers are suitable for all different chemistries which are commonly used. It's possible if there's a new chemistry or technology of the battery technology coming up, we can develop a suitable algorithm for that battery pack and have it programmed in our charger. And yeah, we could replace the old algorithms out of the 25 and add in the new ones. So that shouldn't be a problem.
Okay, looks like we've reached the end of our questions, and they were great questions. Thank you, everyone, for submitting those. Because I'm a marketing guy, I can't resist giving this a little plug. Great way to stay connected with Delta Q. If you just follow our LinkedIn profile or Instagram, you can scan the QR code or just look for us when you're on LinkedIn or Instagram. So great way to keep in touch with what's going on with Delta Q, new product announcements, trade shows, that sort of thing. So, okay, finishing off the today's webinar, we have Sunil's email address and phone number there. If you wish to reach out to him with any other questions that you may have around the RQ series. But thank you very much. This does conclude the product webinar for today. So on behalf of Delta Q and our parent company, Zappi Group, we'd like to thank you for tuning in. And we do hope you found the content useful and informative. So reach out to Sunil, the RQ Series product manager, if you do have any other questions or thoughts. And anyway, thanks again, and we wish you all a pleasant day or evening. So take care, and we'll see you soon. Thank you.
Thank you.
Thanks, everyone.